So, we are going to spend some time now talking about objects. So, if you remember way back when we talked about there are two types of variables, there are primitive type variables and there are object type variables, right? Primitive types are built into the language, it can only hold a value. Object types can hold 0 or more values and potentially do more. So you can almost think of objects as super variables, if you will. Up to this point, we've used some built-in objects. Before today, we'd use string, we'd use character. Today, we use random, we use big integer. So we've utilized some built-in objects, and there's tons and tons of them that are built into the language. But we can also create our own objects. Now, historically, there was this idea of a struct. So struct is from the C programming language. C was a procedural language. The idea is there was a need in procedural languages to store multiple pieces of information under a single variable name. Okay, and we sort of talked about this a little bit last class, and our homework assignment that was due today kind of was based on that. Like, okay, we need to store a fraction, so we're going to store the numerator in bucket 0 of an array and the denominator in bucket 1 of the array. We just have to remember that's where we put crap. Okay, now with a fraction, not the biggest deal in the world, right? Remembering two places, but we can certainly understand how that can get out of hand pretty quick if we're trying to remember 30 pieces of information or something like that. Okay, so there needed to be, there was a need for a single variable name to house multiple pieces of data in a more descriptive way than arrays. Okay, arrays pull it off, but they're not descriptive. We have to remember what we put at bucket 0, what we put at bucket 2, and so on and so forth. So in older procedural languages like C, there was this thing called a struct. And structs were a collection of variables. And their values. So under a single struct, so for instance, you could have a struct for a customer record. And maybe a customer record held 3 pieces of information: name, phone number, address. 3 strings. So you'd have 3 strings stored inside of the single customer record struct, but instead of remembering that their name is at bucket 0, their phone number is at bucket 1, and their address is at bucket 2, instead of remembering that, a struct would allow you to literally have phone number, address, name as named values within the struct. Okay, so we could say, let's say their customer record was called C1. We could say C1 dot phone number equals and access it. So it gave us a more descriptive way of dealing with things. But structs had a weakness. And that was just because we thought all we needed to do was hold values. The reality is we also need to operate on those values. So structs allowed us to hold data, but it didn't allow us to manipulate data through methods, through functions. So that's where object-oriented languages were really born. The weakness of a struct, it almost growing out of procedural programming and saying, okay, this is great, but we really wish we could do more, led to the birth of object-oriented languages like C++ and then later Java and C#. Because these guys gave us objects. An object is a collection of variables in object-oriented terms, these are called fields. Constructors same name as the class, and methods. class and or instance. You can have a single class that has both class and instance methods in it. And that'll make sense once we start writing these. Okay. So an object is like a superstruct. It's not just a collection of variables. It also has constructors to teach us how to build them. And it also has methods that allow us to do things with our object. Okay? So let's start off by looking at writing our own object. And we'll base it off kind of what we were doing today. I'm going to create a new object. So I'm going to create a new class inside of our project. I'm going to call this guy dice. So kind of like playing dice. You know, you got the casino rolling dice. Okay? So I'm going to create a dice class. And dice classes, well, a dice object, if you think about a dice, typically dice have a number of sides, and we might also have a quantity of dice. Correct? But let's just start off with number of sides. So I'm going to say that dice, again, classes are collections of variables, constructors, and methods. Fields, constructors, and methods. So I'm going to define some fields. Fields are defined here. They actually don't have to be in any certain order. They just can't be inside of each other. You can't put a field inside of a constructor. So general naming convention says fields get defined first, then constructors, then methods. So I'm going to define my fields here. So I'm going to have an int called sides. All right. So one of the things a dice object keeps track of is going to be sides. Okay, let's keep this simple. Now, if I do nothing, in fact, let me even take sides out just for a minute. I'll put it right back in. Okay. Right there I have a class, dice. I'll come into my driver. I'll take this stuff out of main, so we can have main to play around with. I'm going to go ahead and create an instance of my dice class. Dice D is equal to new dice. System.out.println D. What should display to the screen? Memory address. Why? Because we see the new keyword. Okay, there's our creepy memory address. So literally, I just built an object, and what is it? It has nothing in it. Public class dice, open and close and curly brace. Done. Objects. Okay. But we notice that I was able to call the constructor here, dice, even though I didn't write that constructor. Notice inside dice, I wrote nothing. You don't have to look real long to see that I didn't write anything in there. Okay? Yet, we are still given a no argument constructor. In the event that we do not write our own constructor, we will be given a no argument constructor, a constructor that takes no parameters, that does nothing except support this syntax. Okay? But in our case, when we build a dice, we want to be able to pass in how many sides this dice has. That way we can build a 6-sided die, and an 8-sided die, and a 12-sided die, so on and so forth. So I'm going to go back over to dice, and I'm going to put int sides back in. And then I'm going to go ahead and I'm going to make my constructor. Public dice. This guy will take in an int s. I'm going to change that here in a second. And we're going to say sides is equal to s. Okay. So now, because I've provided my own constructor, now notice, constructors have the exact same name as the class name. That is a requirement. Must have the same name. Capitalization and all. Notice that constructors look a lot like methods. Correct? They both have parameter lists. So now we've added a little bit of confusion into the thing. How can we tell if something is a method or a constructor? Well, if you're looking at the definition of it, it's super easy on two different levels. Constructors always have the same name as the class. You'll also notice that constructors do not have a return type. Why do constructors not have a return type, do you think? I promise you, 100% of the time, that a call to a constructor will always follow the new keyword. Why is it, do you think, that constructors do not actually have a return type? In older languages like C++ and C, well, C constructors didn't exist, C++, there would have been a return type. But in Java, they've removed that. One of the things they do in Java is they've taken a lot of redundancy out that we didn't have to deal with before. Last class we talked about in older languages like C and C++, you were allowed to, the programmer was empowered to make bad decisions like handing somebody the house instead of the address to the house. Never makes sense, but the language allowed you to do it. Similarly, older languages made you put a return type on constructors. I'm telling you that constructors will always come after the new keyword. What does the new keyword always do? Boils down to a memory address, right? It's a real estate agent. So would it then follow that constructors always return a pointer to where they live in memory? Yeah, 100% of the time. So why have a return type if they always have the same return type? Make sense? Okay. So that's the punchline there. So inside of dice.java, constructors never have a return type because there is only one return type for constructors. Constructors are treated as special cases. So constructors always have the same name as a class, and constructors never have a return type. But all the other rules in terms of parameters are just like methods. They can have 0 parameters, they can have 50 parameters, however many you need. Okay, in this case, we want one parameter, and that one parameter, we're going to take in an integer, and we're going to set sides equal to that integer. Okay? Now, first of all, I'm going to tell you never write it this way. We're going to fix it. We'd write it close to this way. But this is very bad programming as we currently have it written. But before I go into that, let me at least show you what this guy can do so far. So as of right now, I can come out here, I can say, now notice it doesn't like the syntax anymore. Because since I provided my own constructor, since I wrote one, it no longer gives me the no argument one. It's saying, hey, there is no constructor that takes no parameters. So I now have to use the constructor that I wrote, the one that takes an int. So when I build a dice, I'm going to pass in the number of sides. So I'm going to say we're going to have a 6-sided die there. Now I can go ahead and print out D again, and we see that D was the memory address, but I can also say D dot sides. Now I can get that 6 out of there. So I built my dice object by calling its constructor that takes in an integer. That constructor takes that integer, sets its field sides equal to that integer, and that's all this object does right now. But now I have something that I can build and easily access the individual variables. D dot sides, F dot numerator, F dot denominator, so on and so forth. Make sense? Okay, so now, like I said a second ago, this is never good syntax. Why? Java is not a descriptive language when it comes to method definitions and constructor definitions. We don't necessarily know what S is. We want to use variable names that are descriptive. Well, since this is the number of sides for a dice, the most descriptive variable name would be sides, correct? But then we have a problem. Inside here, I'm saying sides is equal to sides because I have a field name sides and I have a local variable name sides. So what am I doing right here? First of all, if we run this, we see our output is 0. That's the default value for an integer. Not that you should ever rely on that, but that's what the default value of an integer is. Because what's happening? I'm passing in 6 for sides right here. Then we're setting sides equal to sides. This is a variable. This is a variable. Variables resolve to their most local definition. The most local definition of sides is not this guy. It's this guy. So the most local scope for sides is this guy right here. So what am I doing? I'm setting this guy equal to himself. And I'm never changing the value of this guy. That's what the code's doing currently. Not what we want, right? But you know what? What we really want is we want to have our field name sides because it's the number of sides for a dice. And you know what else we want? We want the parameter for our constructor to also be called sides because that just makes sense. If somebody calls our constructor, they should be able to pass in a variable. They need to know what kind of value. They know they're passing in an int, but what is this int supposed to represent? It represents the number of sides. So that's why we want to call it sides. So we have to have a way of distinguishing between these two. And the way we do it is with the this keyword. This, I'll put it in double quotes. This is how an instance of an object refers to itself from within itself. So like if I'm talking about me, myself, I don't say, well, Mike likes this, Mike likes that. People think that comes off weird, right? Instead, you say, oh, that's my favorite food. Or look at me. Okay, so when I refer to myself, I say me, my, whatever, that kind of stuff. I don't say Mike. Similarly, if we are inside, dice, the way we refer to ourselves is this dot. So I'm saying set my sides variable, my field, the field that belongs to me, equal to the value you just passed in. So this dot sides is equal to sides. That make sense? Go ahead. Why I have driver and why I have dice? Yeah. Yep. Remember way back I said all programs begin and end with main. Notice that dice does not have main in it. So when I create my own objects, it's a good question. When I create my own objects like this, I'm purposely not putting a main in here because I do not intend to run dice directly. I intend to use dice as part of the solution to a problem in another program, inside my driver in this case. Okay, so inside driver, I build dice and use dice. But driver is the guy who actually runs my program because that's where main is. But there's nothing that says I couldn't have an entire, all my logic taking place in dice and having driver create an instance of dice and saying d.start or something like that. So you can pass control over to somebody else. But you can only have one class inside of the package. So right now we're just using this default package. So one class inside of the package that has main. Otherwise it gets confused on which guy to call when you run it. Okay? So the guy with main is who gets called when we hit the play button. All right. So this is how an object refers to itself within itself, how an instance of an object. And what I mean by that is if I created, so right now I have an instance of dice called D. I can create a second instance called D2 of dice and pass this guy 8 for his number of sides. We have D dot sides, we have D2 dot sides. Make sense? Okay. So when I print this, D dot side should be 6. D2 dot side should be 8. 6 and 8. Now to kind of prove how this works, I'm going to create my two objects here, and then I'm going to print them out. But I'm printing out D and I'm printing out D2, so I should see the memory address, correct? We'll talk about why, but that's what we'll see. So we're going to see two memory addresses. Now, I've advertised that the this keyword is how an object refers to itself from within itself. To prove this, inside of my constructor, I'm going to say system.out.println this. I will print out myself. Saying system.out.println this is equivalent, for D, is equivalent to me saying system.out.println D. But when I'm inside dice, I don't know that the variable name that pointed to me was called D. I only know how to call myself through this. So what we're going to see here is we're going to see me create both of my objects, D and D2, and inside of that constructor, we're printing out their memory address. And then we'll see the exact same two memory addresses print out here, proving that these guys are pointing to the same place. It's the same memory address. F7, F7, 8C, 8C. They're the same guys. So externally, I have a variable named D, which holds a pointer to a dice. If I print out D, I can get D's memory address. Internally, if I'm inside of that instance D, this is how I refer to myself. That make sense? Okay, so this keyword, very, 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 very important. Now, before, we were doing something like this. D sides and D2 sides. And we saw that printed out 6 and 8. Okay? And those memory addresses are coming from our constructor right here. So just as I said, good programmers would never artificially name their parameters differently than their fields, just so they didn't have to use the this keyword. I'm also saying that programmers would never, at least generally speaking, access variables directly like this. Why is that? Nothing keeps me from saying d.sides is equal to 13. And then when I print out d.sides again, I have externally changed it. So d.sides, I built with my constructor. I passed a 6 in. This is supposed to be a 6-sided die. Okay? But then I externally changed it to 13. Print it out again. Now it's 13. So I'm giving somebody else full access to the value in my variable. Read and write. That's considered to be bad programming practice. So that's where security keywords come in. security keywords. We have public, private, and protected. Public means everyone in, let's just say everyone can see it. Private means can only be seen from within the class. Protected means can only be seen from within the class or children of the class. We're going to talk about something called inheritance. That is when you have one class borrowing some of these things from another class. Okay? We're not going to talk about it quite yet, but I'm just telling you it exists. Just like we inherited stuff from our parents. So we have same color eyes or something like that, but they had their own traits, we have our own traits, but some of those traits were passed down. The same thing's true with inheritance in object-oriented languages. In fact, inheritance in object-oriented languages is part of how object-oriented languages are created. And I'll come back and talk about that. Let me just actually create a slide for it so I don't forget. We're going to talk about the object-oriented programming hierarchy. All right. But the point I'm making right now is programmers would not do that. D.sides is if you were writing a quick little object to hold on to some stuff and you were the only person who was ever going to use it, probably not a big deal. Generally speaking, though, if you're writing code that's going to be portable, somebody else might be maintaining it, that kind of stuff, you want to make your code as locked down as necessary. So what I always tell people is when you're making a class, classes are, remember, they're collections of fields, constructors, and we'll put a method in here in a little bit. Make all fields and all methods as private as possible. So I'm going to start this guy off as private int sides. And by our slide, what does that mean? That means that this variable, this field, can only be accessed within this class. So I can only access sides if I am inside of the dice class. So by putting the word private out there like that, if I come back out to my driver, we'll see it's now screaming at me. Dice.sides is not visible. It's not saying it's not there, it's just saying I can't see it because it's private. And because I'm not inside the dice class right now, I can't access it. All right? So we're not giving them direct access to it. Instead, we can give them access through methods. By giving them direct access, we're giving them read and write privileges all open. It's like leaving the door to your car unlocked with the keys to the ignition. Somebody can jump in and take off if they want. Okay? By leaving our variables unprotected, somebody can change our variables. You know, it seems like, oh, well, how important is the stuff I'm writing? A lot of the hacks and stuff like that you read about in the papers, you see in the news, they're not all from this kind of stuff, but not that dissimilar to this type of stuff. Little bugs that programmers put into their code, things they didn't think about, create backdoors that somebody else can repurpose. A hacker or something like that could repurpose and get into systems. Okay, it's not that it was a programmer's fault because they didn't really make the mistake, and the mistake, well, they didn't purposely make the mistake, and the mistake they made didn't immediately lead to somebody else breaking into the IRS or something like that. Somebody repurposed the bug and said, oh, since this bug exists, I can utilize it to also do this. Something like that. So Good rule of thumb is make things as private as possible and then loosen the reins as you need to accomplish the problem you're solving. Okay, so I'm going to make this guy private, which I already did. And that means I cannot directly access him out here. But if I still want to be able to get the value of sides, I'm going to need to create a method. Okay, so accessing private members. Historically, these were called accessor methods and mutator methods. Nothing special about them. A method's a method, a method. But they called methods that provided you access to a private variable. They called those accessor methods. Variables that allowed you to change a private variable were mutator methods. Typically today, they're called setters and getters. That's what they're usually referred to today. Setters let you set the value of a private member. Getters allow you to get the value of a private member. And this is just verbiage. Nothing to do, it's not like a new special kind of method or anything. We're going to go write a getter real quick to allow us to get the sides. So I'll come into my dice class. Inside the class, but outside of the constructor, I'm going to write a method. I'm going to make this method public because I do want everybody to have access to this. This guy's going to return an int, and it's going to be called get sides. And I'll return the sides variable. Quick question before we go and test this. Did I need to say this dot sides here, or could I have just said sides? The hint I'd give you is all variables resolve to their most local definition. What is the most local definition of sides? Is there sides defined here? No. The next most local is right here. These two guys are separate environments. They don't interact with each other. But both of these guys live within the larger global environment of the dice class. So any variables that we defined as fields as part of the dice class govern both of these. So if I'm inside get sides, my most local environment is the one from my parameter list. I don't see a variable defined there. So I'm going to look one step more global. I see sides here. So did I actually need this keyword to refer to this guy? Or was it the only sides that was available anyways? It's the only sides that was available anyways. So I don't actually need this keyword. Having said that, I would strongly encourage you to always use the this keyword for two reasons. First reason is it's never wrong. If you know you mean that guy, say this dot and it's never going to be wrong. So there's never a time where, well, am I supposed to use this or not supposed to use this? If you're asking yourself that question, yes, use this. It's always this unless you're using a local variable. Okay, but if you mean this guy up here, use the this keyword. The other advantage of this keyword using something like Eclipse is if I type in this and then put in a dot, it gives me all my options. So I can just put in the S for sides, press enter, and it spells it out for me. So I don't have to worry about misspelling my variable names. So two conveniences. And actually a third if you talk about performance. By specifically saying this dot sides, it actually saves time at runtime for it to figure out the scope of that variable. It doesn't have to go and look through the scopes. It goes directly to the field level. So it's faster this way. It's less error prone this way. And it's never wrong as long as you mean the fields. Lots and lots and lots of good reasons to put this dot there even if you don't need it. Make sense? All right, so now I've provided myself, this would be called a getter. Or an accessor, historically. All it is a normal plain Jane method, and I don't even need to make it public if I don't want to. There's actually a fourth security thing. If you don't put anything, the default is called package level, which means anything that lives within the same package as you're in, which in this case I'm in this thing called default package, because I didn't give it a package name. Anything within that package can access it. So I don't actually need to put public in front of it, but I like making a habit of specifying whether things are public, private, or protected. Okay, so I would say put public in front of it. It's not wrong not to. That doesn't mean that it's right. Just because it's not wrong to leave it off doesn't mean it's right to leave it off. That kind of makes sense. So I'm going to make this guy public because I definitely want people to be able to access this. Okay, I'm allowing them to gain access to this private field that lives within the dice class. But read-only access. They can't change sides this way. They can ask me for the current value of sides, but they can't modify sides. Sides is an int. They don't get a pointer, they get a value. Okay, so if I'm out here in driver, I don't say d.sides. Now I say d.getSides. d2.getSides. And this will give you my 6 and my 8. What's getSides there? If this is the first time you had seen this, I just showed you this code, and I asked you to tell me everything you know about getSides, what would you say? It's the first time we can say, oh, well, here's the answer, but also we wrote that, so let's go and look and see what we wrote and why we wrote it. So what's getSides? It's a method. What kind of method? Class method or instance method? And first of all, how do you know it's a method, not a constructor? How do you know getSides is a method and not a constructor? Because methods and constructors look very similar. What's different about constructors versus methods? Constructors are always named the same as the class, and constructors never return a value. So the best way for us to tell whether or not this guy is a method or a constructor, well, and there's actually a third way. Where do constructors always appear? Immediately following the new keyword. Are we immediately following the new keyword right here? Nope. Does it look like a method-y type thing? Yep. Must be a method, not a constructor, because the new keyword's nowhere to be found. So not named the same as the class, not driver, but not named dice. So it's not named the same as the class. Seemingly doesn't have a return type. Well, seemingly does have a return type here, which means that probably not a constructor, since constructors don't have a return type. But most important to us, most obvious to us here is because it doesn't come following the new keyword, not a constructor. So this guy must be a method. Okay, so it's a method. Class method or instance method? Instance, how do you know? Because we're calling it with an instance of the class in which it was defined. We're not calling it by saying dice dot. We're calling it by saying d dot or d2 dot. So that means when we go and look at the actual implementation of this method, we come over here to the dice class, we should not find the static keyword out front, right? There's getSides, no static keyword. Why did we choose to make this a instance method rather than a class method? Up to this point, we've written class methods, we've used class methods, and we've used instance methods. And we just wrote our first instance method, I guess. But before now, we really haven't considered why would somebody write an instance method versus a class method. We've always just kind of, well, because. It's kind of, we'll talk about that later. Why do you think we made this an instance method? By making it an instance method, it affords us, well, by making an instance method, every single instance that we create of the dice class gets its own copy of this method. And this method, that particular copy, knows everything there is to know about that particular instance, including what its fields are. So if I'm out here and I say D, call your getSides method, this calls D's getSides, which knows that this .sides is equal to 6. This guy calls D2.getSides, and that getSides method knows that this .sides is equal to 8. So instance methods allow us to manipulate and retrieve values on a per instance basis of a class. We want to create many dice objects. So we want to have instance methods in there since those methods are going to operate on different instances of dice. Just like the length method for strings. I want to be able to create 20 different strings and have the length method tell me how long each of those individual strings is. I don't want there to be a global. So as an example, if I came into dice here and I'm just going to create a class method. Well, here we can just do them by example. We'll call this getSides2. Okay? And I'm going to say return this .sides. And right off the bat, it's not happy with me. It's going to talk about, I'm calling this from a static context. Cannot use this in a static context. This is how an instance of an object refers to themselves within themselves. When I have a class member like this, by putting static out here, I am coming from what's known as a static context. So anything I do in here is happening at the class level, not at the instance level. And the class only has access to the members that belong to the class, not that belong to instances of the class. So if I had a separate variable up here, private static int sides2 equal to 7 or something like that, if I wrote that, I could say sides2 here. That's legal. Why? Because that guy belongs to the class. He's a class member. Every single instance of the dice object has access to this variable, but that variable only exists once. Every single instance of the dice class gets access to this variable, and that variable exists once per instance. This guy exists once ever. This guy exists once per instance. So static means something only exists one time. And you cannot utilize this if you're inside of a static context. Now, it will be fairly rare for you to ever find a class or for you to write a class that has both class methods and instance methods in it. Usually, whatever problem you're solving will dictate you to have a bunch of class methods or a bunch of instance methods in it, something like that. So, as an example, I'm going to go ahead and create another class called Fun with words. Okay, so here's my fun with words class. And inside here, I'm going to give myself a public static get vowels method. And we're going to have this guy return a, well, we'll do a little work here. We'll have him return a string array. Of vowels. So what I'll go ahead and do is I'm going to say string array answer is equal to A, E, I, O, U. We'll just assume they're all lowercase. We don't need to go anything farther than this for our example here. So I build a little method here, or a little array called answer, filled up with all my vowels, and then I'll go ahead and return answer. Okay, so inside this Fun with Words class, I have a class method called getVowels. I only need one dude to remember what all the vowels are. I'm not going to create instances of Fun with Words. I'm going to ask my Fun with Words class to remind me what the vowels are. Okay, so out here, when I call upon that guy inside driver, I'll say Fun with Vowels, or I'm sorry, Fun with Words dot get vowels. I'm calling it using the name of the class. So I'm saying, give me some information about vowels, not about a particular instance of Fun with Words vowels. Does that make sense? That's an example of when we might use a class method, where we're almost creating a library of stuff to operate on inputs. All right. So at the end of the day, it's an instance method if you need to create multiple instances of this guy. If you're only going to use him once, like we're using Fun with Words, to whenever we need to remember what the vowels are, when we need to remember what the consonants are, or get today's date, whatever it is, we can go to a one-stop shop for that. We go to Google. We don't go to an individual instance of Google. There's only one Google. That make sense? Okay. So back to dice. Here's an example of our getter for getting the number of sides. So we set our sides through the constructor only once, but we're not allowing them to modify the number of sides for a dice. Now we're going to create a quick little method, public int roll. And we're going to roll this number of the sides of dice. Okay? Well, how does that work? Well, we've seen the random class. We can generate a number between negative 2 billion and positive 2 billion. We can then make that number a positive number. We can then make that number between in this case, we want a number between 1 and sides, as opposed to 0 and sides minus 1. Okay, so I'll create my random class. Random r equals new random. It's going to want me to import java.util. I'm going to end up moving this here in a few minutes, but for right now we'll put it locally. I'll talk about why we move it. So I'm going to import java.util.random. Now we have access to it. Then I'm going to say int num is equal to r dot nextInt. So we'll roll it once. Right now we know num is some number between negative 2 billion and positive 2 billion. If num is less than 0, num is equal to num times negative 1. Then we want to return num mod this dot sides You want to return whatever that number is, plus 1. Because if I mod it by size, I'll get a number between 0 and sides minus 1. I want a number between 1 and sides. That's why I added 1 to it. Because if I'm rolling a 6-sided die, I can get a 1, 2, 3, 4, 5, or 6. Okay? So we just taught our dice how to roll. So I go back out to driver. I created my 2 dice. I created a 6-sided and an 8-sided. So I'll say for int I is equal to 0, I is less than 20, I plus plus, system.out.println. Now this is a method called roll. Is the class method or instance method? This is its definition. Class method or an instance method? Should be getting real quick now at this. This is the method definition, not where I'm using it. This is the definition. Is this a class method or an instance method? Here, class method. Here, class method. What else we got? Instance method. And method definition. How do we tell the difference between a class method and an instance method? One word. If the word static is there, it's a class method. If the word static is not there, it's an instance method. In my defense, the first time I told you that, I said we're going to drill that into your soul. Eventually it'll stick. So this guy is an instance method. Why? Because there is no static. How do we call instance methods? We call instance methods using an instance of the class in which the method was defined. This method was defined inside of a class called dice. So we need to call it using an instance of the dice class. I just happen to have 2 here, D and D2. So I'm going to call D.roll 20 times and display it to the screen. So we should get a bunch of numbers between 1 and 6. There's a bunch of numbers between 1 and 6. If I call D2.roll, I should get a bunch of numbers between 1 and 8. So there's a 7 there, there's an 8 there, so we saw that it truly took sides into consideration. That make sense? Okay, so we taught these guys how to roll. Now, back inside dice. I can roll the dice. We're going to create a method, public void display. And for a dice, we're going to say system.out.println. Now, usually a 6-sided dice would be called a D6. A 20-sided dice would be called a D20, so on and so forth. So we're going to create a representation for our dice. So I'm going to print out the string D concatenated with this dot sides. So whenever I call display, now is this a class method or instance method? I have 1 vote for instance. What does everybody else vote? Instance? I have half voter turnout at this point. Is this guy a class method or instance method? Instance. Why is it an instance method? No static. Instance method because of no static. When you're looking at a method definition, whenever you're asked, is this a class method or instance method, immediately look to see if you see the word static there. If it is there, it's a class method. If it's not there, it's an instance method. All right, So I wrote this display method. It is an instance method, so we call it with an instance of the class in which it was defined. This guy was defined inside of the dice class. So we will call him using an instance of the dice class. And what does this method do? It just displays some crap to the screen. What crap? The hard-coded string D concatenated with however many sides this particular instance has. So I'll come out to driver, and I'll say D dot display D2 dot display. So we should see D6, D8. Okay. Now, let's say system.out.println D, and we'll say system.out.println D2. And what's going to print out? Crazy memory addresses, right? We're about to get to the punchline. Actually, at our current rate, we might actually get out a little early. Well, I wouldn't count on that, but sometimes it's, I'm giving you hope, false hope. We're a little ahead of the curve right now. All right, so D and D2. These will print out 2 memory addresses, right? Wouldn't it be lovely if instead of printing out the memory addresses, it printed out D6 and D8, a string representation of our dice? That would be desirable, right? Okay, let's talk about why big integer worked the way it worked, how we're going to make ours work that way, and why the other ones, why this guy currently works another way. There is some invisible crap going on here. More invisible crap, just like in constructors, where we have no return type here because it's always a memory address. There is something missing up here in our class. That was invisible. And I'm going to run it right now. It'll still work just fine. This was here. Why was it there? Because that's how object-oriented languages are built. And this is back to that hierarchy slide I started writing. Somewhere. Object-oriented programming hierarchy. All right? In every single object-oriented language, there exists a top-level object called object that all other objects inherit from. And just to prove this quick point, I'm going to go back to our Java documentation. Big integer. I'm going to scroll up all the way to the top. The top of any documentation page in Java gives you the hierarchy of this object. And at the very top of that will be object. I don't know how many guys are going to be in the middle. This guy might be 5 or 6 generations down on the tree. But at the very top, you'll always find object. Object. So this guy is a big integer, which is a number, which is an object. Make sense? That's inheritance. So if I'm Mike, my dad was Larry, and his dad, I don't know what my dad's dad, we got to go my mom's side. If I'm Mike and my mom was Gail, my mom's mom was Dolores. Shouldn't I know my dad's name? He died when my grandfather, right? Yeah, my grandfather on my dad's side died either before I was born or when I was like really, really, really young, which is interesting because my dad's mother lived for like 1,000 years. Like there was some discrepancy on like what her age was when she died. But my mom's parents are still alive, so I know them. Actually, my grandpa called me during class. So I got those names. They're fairly old at this point, but they've lived a pretty good life, long and kicking. So anyways, that's the hierarchy thing that's going on here. But the very, 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 very top of every, I don't care what guy I click on, If I go back here to java.lang, the core language, and I just root around in here, I just pick one. Object. Process. Object. It'll always be the top level. That's how object-oriented languages are built. So whoever originally wrote Java, or any object-oriented language, sometimes they don't call it object, sometimes, for instance, Objective-C calls it NS object. C# calls it object with a lowercase o. Completely different, right? You get the point. But when they build it, they build this core object called object and build into it all of the generic stuff that is common to all objects. Okay? All of the generic stuff that's common to all objects. So if I come in here and I click on the object class and we go and look at that object class, we'll see objects are pretty simple. It's not, I mean, we're already on description. So that's everything that's in an object. Clone, equals, finalize, get class, hash code, notify, notify all, toString, and that's an important one. We'll come back to it in a second. Wait. 3 different waits. What's it called when we have more than one method with the same name but a different number and or type of parameters? Polymorphism. So here's another example of polymorphism right here. 3 methods that it's waiting on a thread to finish. Not unimportant what it does, but there's 3 different ways to do it. Okay. Whoop. Stop clicking. All right. But we have this method called toString. And this guy returns a string representation of the object. Now remember a few minutes ago I said there's hidden crap? We have hidden crap, right? Go back into Eclipse. Not only was this hidden, but if I come into driver where I'm printing out D and D2, I'm going to show you some more hidden stuff. It's calling D.toString, D2.toString. I'll run this, same output we had before. Crazy memory addresses, our display methods worked as we wanted them to. ToString, class method or instance method? It's an instance method. How do you know? We're seeing it being used here, not being defined. Static only matters when we're looking at the definition of methods. Now we're seeing it being used. How do we know this guy is an instance method? We have to look at how it's being called. Who is calling this guy? D, which is an instance of the dice class, not the name of a class itself. Instance methods are called by instances. Class methods are called by class names. Okay? So this guy is an instance method being called by the dice class. So we should go in here and we should find the toString method inside of our dice class, correct? Do any of you remember writing that? I don't. You come in here, not in there. But yes, it is. Why? Well, because we also are an object. And we got everything from our parent object, including all of their methods. So I have a toString method here that it literally is the same toString method that object gave me. And what is object's toString method? We already just showed that the println methods utilize that toString method. They assume it's there. We saw more hidden stuff there, right? We saw that what println is doing, it is calling whatever dude you pass it, it's calling his toString method if you pass him an object. Okay, so that's a how Java is built thing. So if we want a guy to display a certain way, we need to override his toString method. Because the default toString method that every single object is guaranteed to have, because every single object at some level is object. So at the very least, we got the generic one that object handed down to us, which shows crazy memory address thingy. But we can come in here and say, you know what? We want a better version of this, public string toString, and this guy's just going to return blah. So I went ahead and I overrode the one I got from my parent. Now, that doesn't mean my parent's one is gone. This is just like variable scoping. When we call toString, if I'm out here in driver and we say d.toString, it will look for the most local definition of toString. So it'll start off by looking inside of dice, and it will find toString right here. But had we not written it there, it will look inside of dice, see that it's not there, then climb up the hierarchy to whoever this guy's parent is, and keep climbing until it gets to the top level object. And if it doesn't find it there, then it screams at us and says, this method doesn't exist. Okay? So because I wrote this toString method here, I have just inserted a more local definition of this method than the one I got from my parent object. So now, when I hit play, I get a couple of blahs, not crazy memory addresses. And just to prove this is true, I'll go ahead and take the toStrings off here. We'll let them go back into hiding. And I'll go ahead and call it again. And we still see it goes to blah. Indeed proving that it is calling that toString method. Now, what if we really, really like the crazy memory address thing, but we also want to throw in our own little jazz? Well, if I'm inside dice and I'm writing my own toString method, I have to return a string. Who has the crazy memory address thingy? My parent. The this keyword is how an instance of an object refers to themselves within themselves. The super keyword is how an instance of an object refers to the instance of their parent within themselves. So when I refer to my dad, I'm not saying, well, when I refer to myself, I don't say Mike, I say me. When I refer to my dad, I don't say Larry, I say my dad. So my dad, when I say it, is kind of like super is in the code. Okay? So if I'm in here and I want to take advantage of my parents' version of toString, I can say super dot toString concatenated with space, smiley face, arrow, blah, there, blah. Makes plenty of sense. So what's this going to do? When it calls toString, it's going to find my most local definition of toString here in dice. What does this guy do? He borrows the result of his parent's toString, so object's toString. So I'll get the crazy memory address here as a string. And I'll take that, I'll concatenate onto it a smiley face followed by an arrow followed by blah. And now we see we've put the two of them together. We liked the memory address. We just didn't want to only have the memory address. Now, having said that, we might at a glance say this is a waste of time. It actually is not. Especially when we're dealing with pointers. When I introduced the this keyword, I printed it out using this, and I also printed it out externally using the variable and proved they were the same address. These are truly unique memory addresses. Okay, but it's a memory address within the Java virtual machine. Remember, the Java virtual machine is a fake computer that lives inside of your computer. So it has its own memory subsystem that it's utilizing. So everything is virtualized. So even though your computer, your operating system has its own memory structure, within that you have a program called the Java Virtual Machine. And that program has its own sub-memory structure, which is allotted just out of the memory that was given to that program. So the Java virtual machine really is no different than like Microsoft Word. It's given a block of memory that it has to work with, and anything bad that happens in there lives and dies with the Java virtual machine, just like Word can crash without your computer crashing. Okay? It's actually one of the safety nets of Java. I probably pointed out maybe the first class, or if not, maybe the second class. One of the problems that older languages like C and C++ had is certainly during the learning curve. I mean, I expect when you guys are working on your homework, you're probably spending at least a reasonable amount of time fixing bugs and wondering why is it doing what it's doing and that kind of crap. Well, that's all part of the process, right? When I started programming, it was the same thing. So when you start programming, we are very, very error prone, right? With Java, no big deal. Hit the little stop button when you get into an infinite loop, try again, hit play again, right? No harm, no foul. In a language like C++, you could crash your computer. You might have to reboot before you try to fix it. Because if you started going off wild and your bug was some memory overwriting thing, you're using real memory, not Java Virtual Machine's memory. Worst thing that could happen for us is maybe Eclipse crashes because you did something that caused the Java Virtual Machine to freak out. That's about as bad as it can get with Java because it's no different than Word crashing. Anything you do, you're doing within Word. So it doesn't matter how many things you click on or whatever, that's all happening inside of Word. Anything we do in here is happening within the Java Virtual Machine. So it's a nice thing about Java, where in a C++ program, it wasn't common necessarily, but potentially you could walk off the end of an array or something like that and overwrite part of your operating system in memory. Not the end of the world. You just reboot your computer and everything's fine, because the stuff still lives on disk. You just have to have it reload the correct crap back into memory, the stuff you just overwrote. But clearly you can see how that could be a nuisance. So think about how much worse this would be if you were writing your homework in C++. You might have to restart your computer sometimes. So it could be so much worse. All right. So, makes sense how toString works? Okay. Questions about any of the stuff we did today with objects? I've shown you some hidden things. This is always there, extends object, whether you write it or not. You don't have to write it, I'm just proving it's there. ToString methods are a very, very powerful tool. It allows us to have objects that can be printed. So, maybe the final hurrah here for us is I'll just take this string that we did in our display method, and I'll have our toString return that. I'll get rid of our display method. So now, when I print out D and D2, it'll print out D6, D8. Because we've taught it how to more correctly display those objects rather than display the memory address. And that's just because we have the knowledge now that the method that the println methods are calling is toString. And we chose to override the one we inherited from object. All right, so big things today. toString, this, super. This is super, 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 super important, pun intended. Okay. Probably the most important thing we covered today is this, the this keyword. Extremely powerful. Even if it seems clear to you now, make it a force of habit to always use it when you can. Eventually, you won't even have to think about it, and it won't make. You'll choose when to use this dot and when not to use this dot. I tend to have a habit of always putting this dot and stuff, not because I need it, because I spend a lot of time coding in front of groups. So it's the easiest way to teach this stuff. And like I said, it's never wrong to put this dot. So I very well might just do it anyways. But that's a very, very important concept. So if you don't understand this dot, that's fine. That's common. Okay, so it's a very difficult subject to teach without saying the word this too many times. So it's kind of interesting. So it's common to be somewhat confused about it, but work really hard to try to gain an understanding of how that works. That's a very important concept that makes life a lot easier for you. Super, less important because you'll use it far less often. Far less often. But we saw a little example there where we used it. Really, the only times I can even think about using super is in a situation like that where we might want to leverage our parents' version of a method partially, or a constructor. Probably next time, well, if not next time, the time after that. We have 2 classes left? Yep. When we actually write our own inheritance, when we insert a layer between us and object. Right now we're going from object to dice. Well, we might go object to dice to purple dice, something like that. It's a bad example, but whatever. When we insert that level in there, we might choose to have our parent's constructor do some of the work for us. So in that case, inside of our constructor, we can partially initialize ourselves by calling our parent's constructor, and then do the things that differ. Okay. Last thing, and I mentioned I was going to do this earlier, in our roll method, right here, I had mentioned I was going to be moving this. Remember that? Okay, the reason is, it's not wrong the way we have it written right now. Inside roll, every single time we call the roll method, we are building a brand new instance of the random object. Not the end of the world, but really a waste of memory. We would be better off defining this guy as a field. Giving it its initial value in the constructor. So now our dice object has 2 fields. It has an integer sides and it has a random r. We gave r its value inside the constructor. From that point forward, after this instance of dice has been created, we have access to a random object named r. So down here, rolls just still works. I can say r.nextInt. Why? Because is there a local variable called r right here? There's not. We'll go to the more global level. Is there a variable named r right here? Yes. When did he get his value? When this dice was created. We set it equal to new random. So now we have the variable and we're only giving it a value one time when we first instantiate our instance. So that's happening right here when we called our 2 constructors, these 2 lines. So D gets his own instance of random, D2 gets their own instance of random. As opposed to D and D2 creating a brand new instance of random every single time the roll method was called. Again, not wrong. In this particular example, probably not the end of the world. But if we roll the dice 100 times, we just ask the new keyword to go and get us 100 plots of land. This is like having a party at your house, and every single time the party's over, you got to destroy your house, build a new one. It's like, well, next party. What's up? It does. This reminded me of I showed this in class earlier. There's a any of you guys watch the TV show Family Guy? Ever seen it? Okay, well, in my class earlier time, maybe you've even referred to him in here before. There's a guy in one of my classes, we call him Amish. Have I told you about him before? Okay. A lot of my students have little nicknames and whatever. Really good guy, really smart actually. We're going to taking 3 of our sophomores and 2 of our seniors to a hackathon a week from Friday. So we're traveling to Iowa 7 hours to compete in a programming competition. It's going to be really cool. And he's one of them that's going, so he's a smart guy. But in any case, first day of class 2 years ago or something like that, or maybe first semester last year, he he made some passing comment that he doesn't watch a lot of TV. So no TV, no electricity, must be Amish, right? So now that's kind of like, lived on. And in any case, the Amish people are known for their barn building. And one of my students brought in this funny video. I still have it open. This was months ago he brought this in. But I'll play it in here real quick.
Suck on this, you furry little weirdos! Enough of this crap! Ezekiel!
So, in any case, kind of a funny, a funny thing, because for a year we've been having oh, how'd you spend this weekend? Oh, we just built another barn, playing along, and so it's funny stuff, I guess. How did I even come? Where did I even get to that? Where do we build something, right? Yeah, I must have been talking about building it. All right, so in any case, that's the rationale for maybe moving random up to being a field, a private field, because we don't need access to it outside of here, right? It's just something we're using internally inside of Dice, but let's just create it one time. Oh, that's right, it was the party knocking down your house every single time and having to rebuild the house. Yeah. So let's just build our random object once, give it a value once, and then use it over and over again inside the instance. Okay? So let's quickly talk about our homework assignment. And we'll get out 6 or 7 minutes early, it looks like. Oh, looks like Marty logged out of there. Six or 7 minutes early is actually pretty good for me. Pretty often I'm trying to squeeze everything in like the last minute. It's less of a big deal in a 4-hour class, but man, 50-minute classes are rough for me. Perfect. So as you can see, this is your homework assignment. It's just to fix this. Oh, good. Well, I'll tell you the coding. The coding thing is this. You're creating an object called fraction. Correct? You'll have to tell me if I deviate. Yeah, so you're creating a class called fraction. Here, why don't you just read it and I'll fill in the blanks.
Create a fraction class that has 2 private fields, numerator and denominator of type big integer. A fraction should be able to display itself. It should also be able to add itself to another fraction, returning a new fraction in reduced form. It should also be able to subtract another fraction from itself, returning a new fraction in reduced form. Implement the test.
Okay. So first of all, remember back when I showed you in big integer, how big integers work with the add method? Like one big integer called their add method and took in another big integer, producing the result. So it'll work a lot like big integers. In fact, they're going to work in terms of big integers because internally we want them to be able to hold arbitrary size numerators and denominators. We're adding one additional piece of functionality. That is the functionality for subtracting numbers. Not a big deal, still common denominator, stuff like that, but now you just have to have 2 methods, one for adding, one for subtracting. Also having the reduction, but you've already seen that big integer has greatest common divisor built into it. So that's the program. So almost write the program that was due for today with one additional field, one additional ability, that is 2 additional abilities. One to subtract and also to display itself. Okay? But write it in terms of an object rather than 2 bucket arrays. That make sense? Okay? And also it should hold arbitrary size numbers. That's why we're implementing it in terms of big integer. So that's the coding assignment. Okay, what's the paper?
Discussing the role of computer programming programming in IT is not. This cannot be further from the truth. Programming is to a computer scientist and an IT professional as a hammer is to a carpenter. It is a tool we use to solve problems. You want the rest of it?
No, let's legit it up. All right, so, and first of all, I was insulted earlier tonight. She questioned whether I wrote that myself or somebody, she thought it sounded Locklear-ish. Every one of those words, I'm the programming evangelist here. That's the only, it actually is interesting. It does sound something like Dr. Locklear would say, but no, that is literally all me, and it's probably like the, I'm going to assume it was a compliment. That's the worst compliment I've ever got. I'll have to tell Gary that tomorrow. I had trouble falling asleep last night. One of my students, they thought my stuff sounded like your stuff. All right. So, should be kind of an interesting paper. It'll be your ability to kind of look into where does programming kind of fit in the big scheme of things. I was telling her at break, I'm a big advocate of this idea. We have in our undergrad program students who, we have two majors in computer science. We have the computer science traditional, and then we have an IT major. Well, people do IT because they think it means no programming. And they're taking all the same classes except one. They skip one programming class. And it's not like they're skipping the programming class that's equivalent to our 537 class in here. So it's that second level of data structures and things like that. But what is, the problem is they come out ill-equipped to go into the IT industry. I tell people that computer science is 75% creation. We're creating tools, 25% utilizing those tools. IT is 75% utilizing tools, but still 25% creation. So the different sides of the same coin, there's a little bit of overlap on the top. So we have to have those programming skills. And something I had mentioned to Faye, you probably noticed she's not with us. She ended up dropping the course. She had some other things going on. But something I had mentioned to her is when you come out of these classes, these classes aren't going to necessarily be easy. Some of you are maybe finding the programming not too hard. Some of you are finding this is the worst thing since sliced bread. It's backwards. But in any case, worst parts of the Bible. That's the better one. All right, so the issue is once you come out, you're going to have an IT toolbox. Here's all the crap that you know how to do. Here's the crap you're good at. Here's the crap you sort of kind of can do. And here's the crap you never want to do again. Okay? And when you're in an IT shop, there will be somebody who's strong at some of those things. So if programming isn't your thing, you have enough of an understanding of it to problem solve within it. And you also have enough of an understanding to say, he is better at it than I am. So let's have him do that. And you know what? I'm going to go re-network the lab. Because maybe he's not very good at splicing wires and crap. There's all sorts of different skill sets that IT people have to have. And they all go into this toolbox. And nobody's the jack of all trades. We're all going to have our specialties. So IT is definitely part of programming. But programming is not IT. Just as computer science is not programming. All right? So that paper helps you kind of explore that. Questions, comments, concerns, bribes. All right, 4 minutes early. I'll see everybody.